Welcome, everybody. Leslie just gave me the finest compliment of my career. She said, I put my finger on the sorest spot, which is, I think, why people hate me, but I think it's also an important thing to do in AI. I was thinking about what we're here to do today, and I thought about Marvin Minsky's famous line of solving vision as a summer project. Does everybody know that line? This is a true story. He thought, this was in the 1960s, he assigned Gerald Sussman the task of solving vision over the summer, of just figuring out stuff you see and having the computer tell you what was out there. That problem still hasn't been solved, but it represents the optimism of the early days of AI. We see some of that optimism now. Not all optimism is correct. I think it's incumbent on scientists, engineers, to figure out. Is there a lot of feedback and echo there? Is that me? How about if I go a little bit further? I think a fundamental job is to figure out what makes something hard. Why is it not as easy as it looks? So 60 years later, we still have not solved vision. Leslie just told me a minute ago, I said, this is really wonderful demonstrations with your robots, but the scenes aren't very cluttered. Why not? And what would it take? And she pointed to perception. So perception still isn't solved. And I've been thinking about Doug Lenat's legacy for a long time. And I think one of the important things that he realized is that AI is not easy, that there are principled reasons why many of the things you might try to do in a summer don't really work, that you need actually a lot of knowledge in machine interpretable form in order to actually solve many of the most difficult problems in AI. We now know, 60 years later, that you can approximate many things, but for example, we face a lot of hallucinations with large language models. We get really wonderful approximations, but for robotics, for example, they're really not reliable enough to trust in the real world. They have lots of problems with factuality and reasoning. And Doug's view was that you need knowledge in machine interpretable form in order to solve the problems of AI. He was one of the most brilliant people I ever met, one of the funniest people I ever met, and one of the most courageous, because he decided that that problem of knowledge was really hard and that he would spend the rest of his career working on it. I don't know too many people with that level of courage. So I'm really honored to help today in this celebration, both of Doug and of the work that he did in the Psych project. We have a panel here. We'll gradually introduce ourselves. And we also have some very special guests who couldn't be here today, but who have known Doug for a very long time and have some interesting things to say. This session that we have today is kind of co-organized. Michael Witbrock and I put it together. I'm going to bring up Michael. I met Michael through Doug the first time I got a tour of Psych. It was actually kind of a code-driven software tour with Michael, who was at Psych and who I think knew the innermost workings of Psych better than anybody else at that point. He worked with Doug for many years. He's my co-pilot today, and I will turn things over to Michael.
Morning, everybody. In 1986, Rommel Hart, Williams, and Hinton put out a paper about backpropagation, which sort of refocused the field and rebuilt the field of deep learning and then deep learning. In 1986, I also started grad school at CMU while this was going on, which had a profound and enduring effect on me. In 1986 as well, one of the first papers by Lenat, Prakash, and Mary Shepard on the Psych project came into place. Now, for deep learning, you might think that it was all the work of deep learning neural network sort of people that led to its success. But actually, a lot of its success was waiting around. Right? We had to wait around until the parallel computing people made decent computers. We had to wait around until the disk drive people gave us the ability to store actually now petabytes of material on tiny little disks, right? We had to wait around until computer networking worked, and then until it led to the World Wide Web. And then we had to wait around while people filled up the World Wide Web with everything that humans had ever written, and then everything that they could imagine producing a ridiculous video about. Right? So, and then after waiting around forever, suddenly we had the material which allowed us to build these very large predictive models that led to the resurgence and the sort of the current dominance of large language models and the associated technologies, the associated sorts of learning. I think waiting around can be very important, and at the same time, in 1986, this first paper on psych was happening. There's been why did it happen? Right? It happened because of a research program that Doug came up with when I was still actually young. Right? So in 1977, Doug put out a paper suggesting that one might acquire a set of rules which would allow you to acquire scientific knowledge. Right? The Psych project, in part, was to provide the basis for acquiring that knowledge. Now, we now know that one way of learning is to wait until people produce enough knowledge where you can simultaneously learn all sorts of things from it, right? And you can do that at scale. That wasn't a reasonable hypothesis back in the 1980s. A reasonable hypothesis was that you should build a core of reliable knowledge and then learn at the thresholds of that knowledge, at the fringe of that knowledge. In fact, there's a 1991 paper by Lenat and Feigenbaum suggesting that learning happens at the fringes of knowledge. And in fact, Leslie just told us that for humans and for robots, learning can, in fact, perhaps best happen at the fringes of knowledge. So, Doug's idea was to build this seed crystal, right, which would enable learning to happen. He predicted that learning would start happening 10 years after he started building that crystal in 1994. Took a little bit longer, but now we have now the environment of deep learning in which that crystal can be placed, right, in which this other kind of learning, this incremental, aggregative and reliable learning can happen. So if we drop this crystal of psych into large language models, which can then add to it, there's a real possibility that we can do kinds of learning which aren't even possible for humans, right? So one kind of learning that isn't really possible for humans is to maintain all of the plausible, reliable scientific models of the world that might exist. Take all of scientific knowledge, work out what the consistent sub-theories of it, all of the admissible consistent sub-theories of it are, and use those as a basis for improving science. This is impossible using human intelligence, but it might be possible using artificial intelligence, and interestingly, a new kind of artificial intelligence, right? Some people think that artificial intelligence or that advanced artificial intelligence is replicating human intelligence, right? We have 8 billion humans. We don't need any more, right? The useful kind of advanced artificial intelligence is doing things that human beings can't do. And one of those things is science at scale. So using systems like Psych, taking advantage of the work that deep learning and all that other work which went into deep learning, perhaps we can actually start doing science accurately and reliably. So with that, I'm going to sort of stop talking. But I think the history of AI is full of interesting ideas that we've now got the means to exploit. And one of those interesting ideas, a large set of those interesting ideas, were ones that Doug Lenat and the people who gathered around him pioneered. I'd like to end my little piece with a sort of a personal observation. Not only was Doug one of the sort of smartest, funniest guys you would ever meet, he was also one of the kindest and most accepting people you would ever meet. I've never worked in a more diverse, more genuinely diverse and genuinely accepting work environment than the one that Doug and Mary Shepard built at Cycorp. And I think this is, although you might not expect that, I think this is also something that we can all learn from. Thank you. And now I think that Gary's going to
I will introduce someone. Is my mic live? Show of hands, how many people here have ever used a tablet? I would assume that's everybody. Either you're lying, you're asleep, or something like that. How many people have ever used a graphical interface on a computer? That should also be everybody, and I'm worrying about those who don't raise their hands. How many people have ever heard the saying, the best way to predict the future is to invent it? Well, the person who conceived of all of these things, the laptop, the iPad, that wonderful quote, is a Turing Award winner who couldn't be here today, but is Alan Kay. Now, Alan Kay, by coincidence, is also the person who introduced me, maybe not by coincidence, the person who introduced me to Doug. Alan would have loved to be here. He couldn't be here in person, but he has sent us a video, and hopefully we can cue that up in a moment.
It's a real gift to celebrate my friend for more than 50 years now, Doug Lenat. He's hard to describe, but he definitely could be considered authentically hyperbolic. He was smarter, nicer, friendlier, funnier, more courageous, worked on harder problems, was more tenacious, yet more flexible. He had more to say, and much, much more. He was also authentically unorthodox. He could really get beyond the distractions of what seems to be to find critical invisibles not in current contexts that open up new ways for us to think. Doug could really think about how to think about how to think. And it's these extra levels that I'd like to talk about. This is in the realm of philosophy, a strange term to use in a computer conference, I know. But my view is philosophy is about all the important things we need to think through but haven't learned how to yet. And here is my first Mount Olympus of computing up to the time I met Doug. A lot of good names, all of them made a huge difference. And besides doing great things, their greatest gifts were new contexts that they found for us to think within and helped us all along. So these contexts are kind of difficult to talk about because our nervous systems are set up to render them invisible. But suppose we grew up in this canyon, and we might even have trouble even seeing the dominant color here. It's just everywhere. And our local cultures are artifacts that are similar to this. And also we have an urge to go forward. We tend to look outward. We tend to look around. And we miss a lot by doing that. So we need special people who can look up to find colors we haven't dreamt of. Doug was one of those special people. He could not only look outwards, but he looked up and all of a sudden there's something new. So my old saying for this is that point of view or context is worth 80 IQ points. And here's how I think it works. If we go to Middle Earth here and to Hoppeton in the Shire, one of the local legends is that there's a vast hoard of silver that lies above in the lost realm of Arnor. People have been trying for decades to find the silver. And then, a very odd hobbit indeed shows up and says, no, the treasure lies over the mountain this direction. And of course he has a very hard time convincing people, but finally a few people do. They get over the mountains and they look around and they don't find any treasure, so they start getting upset. They look in the vicinity of where he said to look. They don't find the treasure. But finally, just one or two people look just outside the lamppost and here's some gold. A whole bunch of gold. And we can imagine corporate executives complaining because there wasn't any silver here. It's only gold. So here's a deep heuristic of the kind that Doug was great at formulating, which is explore around the smartest people you know and try to do it just outside the lamppost. Because geniuses are rarely perfectly right, but they are often very close. Many years ago, Doug and Ed Feigenbaum came up with the slogan, "In the knowledge lies the power." And that actually made a huge, important difference in moving from pure deduction into trying to use something more like science, which is evidence from the outside world codified in various ways. But a few years later, Doug and Guha came up with a much better idea. And my version of that idea is that they were saying is, in the knowledge that the power is in the context lies the power. In the knowledge that the power is in the context lies the power. We have to find the right epistemological frameworks to think with in order to find the kind of knowledge that we actually need. And we can think of the present day and our knowledge that we've learned our entire life as being like this wonderful, comfy old barn. Can't bear to get rid of it. But then there comes a fire, burns everything down. We're very sad. But you know, a 17th century Japanese poet once said, "The barn burnt down, but now I can see the moon." And things look different under moonlight. We can see things we hadn't seen before. We notice different kinds of things. And I think that's the way creativity actually works. If you can get rid of your present in a way that you can actually use what's around you that you can now see better, maybe in an odd way, it'll make an incredible difference. So sometimes the sun and existing structures we have are so bright and so present in our faces to render new ideas difficult and invisible. Sometimes we also need to see by moonlight. Thanks so much, Doug. We love you. We loved you, and we love you.
Wonderful remarks from Alan Kay. I have a couple other people up here who we haven't introduced yet. We have Blake Shepard from Psych, and we have Francesca Rossi, who is the president of the society with which we are today, and a fantastic researcher in her own right. We're going to try to do this as a little bit of a hybrid of a panel with people that are present and people who have sent the remarks because they couldn't be here. So we're going to pretend that Alan has just said all of this on the stage, and I wonder what you think of this, Blake.
Yeah, I'd love to react to that. I thought that was a tremendously poetically beautiful tribute to Doug, and I think honestly there's a lot of subtext there that people who know Doug would understand and resonate with in terms of the images that were brought forth in the presentation and so on. I really love that Alan used a map of Middle Earth as one of his allegories. This resonates with me in terms of how I knew Doug. He really loved fantasy. He loved role-playing games like Dungeons and Dragons. He was a lifelong D&D player. He loved to dress up on Halloween in a wizard costume that his wife Mary made for him. But one of the anecdotes about him as a D&D player I think really resonates here very well, which is that people who played with him always said that he could never play an evil character. It was always good, either chaotic good or lawful good, but always good, not just neutral either. And that just carries over through all of his engagements with psych and with industry. He was always most passionate about being good and doing good in the world. And so he was most passionate about the kinds of projects that were highly beneficent that, so one of his favorites was one where we use psych as an application to teach sixth graders math, which is one of the pain points in American education. And also just all of the applications that we've built with psych to support healthcare and improving people's health and the entire hospital experience for anyone who has to participate in that. So I really loved Alan's presentation quite a bit.
Yeah, so it was really a very moving tribute to Doug. I met Doug in 1987. I was at MCC, although I was not in his group. I was not in the psych team. I was in a different team. And I have to say that I was looking at Doug, from afar a little bit, from another part of the MCC building. And you could see that his team, first of all, his team was always very inspired. You could see all these people with the light in their eyes, working for Doug. And that was, I think, that over the years, then when I was not in touch with him, but then later on with Gary, most recently we worked with him for a AAAI workshop, I think, that was in Austin, Texas, on going beyond the Turing test, and he gave a very important contribution to that to understand really how to evaluate whether machines have intelligence or can reason that goes beyond what is the Turing test. But I think that what I got from what Mike and Gary and also Alan said in the video, I would like to point out, of course, knowledge. The focus here is knowledge, I think, in all of Doug's career and work. And to me, knowledge means also explicit versus tacit knowledge. Like this, I think, resonates with people also that were here in one of the previous invited talks by Elizabeth Spelke about core knowledge in children, and the idea that how are we going to put and to make sure that machines have that core knowledge that is so much needed to be able to function usefully in the world, and not just in isolation. And I think that you mentioned that also together with human beings. Why do we want to replicate exactly a human being? We want to build machines that can work together with human beings, that can complement our abilities, no? And that is also the power of knowledge in the ability to communicate with a human being in a reliable way. And it seems to me that without explicit knowledge, and it's still a question mark, do you need to code it? Do you need to learn it? How much you need to do from one or the other one? Now with large language model, it may seem that learning from huge amounts of data is everything you need to do to get the right core knowledge. But we see that reliability is not the best feature of these systems. And I think with explicit knowledge instead, you would expect to be reliable, to be trustworthy, to be able to use these machines also in high-stake decision scenarios that need those features.
So I think it's worth remembering that the point of psych was never to build a large amount of knowledge by hand. It was always machine learning. In fact, the reason I went to Cycorp was that the purpose of this was to enable machine learning when it wasn't enabled in other ways. I'm sort of thinking about Alan's reflection there and about the pool of moonlight, right? And looking for silver. So what what now is the thing? So Doug was also, people kind of think about him as someone who was like this, focused on symbolic representations, or thinking that those were like the main thing. Again, those were just for him a means to an end. We had many conversations about when we would be able to use neural networks, for example, for concept learning, right? This was in the early 2000s, before people were really seriously trying to do that, and because we didn't have a means to do it. We used CycU was one of the earlier places where reinforcement learning for inference and planning like activities were used. So Doug was very ecumenical. So what would he see as the edge of the moonlight, the pool of moonlight now, right, where we might find that pot of gold of sorts of intelligence which augment human civilization?
Yeah, no, I think that's absolutely right. That's a key point. So Doug's earliest inspirations in computer science were in the field of machine learning, and he was driven to start the Psych project in order to build a foundation upon which learning could mature and become of value, right? So he always had a vision toward leveraging the knowledge that was accumulated in Psych for the purposes of crossing the knee of the curve at some point. So we would manually add knowledge to Psych, insofar as it was necessary, but at some point, Psych would be able to learn on its own. And I really think that we've crossed the knee of the curve now with the advent of LLMs, and most recently in the success that we've had with autonomously growing Psych through having it work with LLMs to build reliable knowledge, and then to serve that reliably built body of knowledge back to LLMs for their own benefit.
No, slightly late, because Doug, in fact, wrote a paper, When Will Learning Happen? Right, where he predicted that it was going to happen in September 1994. So we're only 30 years late. On the other hand, we were about 40 to 50 years late on realizing the hope of sort of a general solution to learning in neural networks. So sometimes patience, as I said, is a virtue. And Doug had a lot of patience.
I'll jump in there myself. I had the privilege of working with Doug at the very end of his life. We tried to write a very ambitious paper, which we ran out of time and did not write. And in a matter of weeks, he kind of rewrote a much shorter version that's on archive. I guess it's Lenat and Marcus came out in July. And in keeping with the fact that he was interested in machine learning all along, the last paper, the final section of the last paper is really about how to integrate large language models and machine learning with Psych. And so we had 5 suggestions, and this paper is really more his than mine, though I helped as best I could. Symbolic systems such as Psych as a source of truth to reject false confabulations. So he was finding different places where they might fit in. Symbolic systems such as Psych as a source of truth to bias large language models towards correctness. Large language models as generators of candidate assertions and rules to add to symbolic systems such as Psych. Symbolic systems such as Psych as a source of inference to dramatically extend large language model coverage. And symbolic systems as Psych as a source of explanations to provide and audit and provide provenance support. So, even in the final months of his life, he was very much saying, how do we bring these things together? So he's often, I think, represented as, and Michael's making this point, I'm just amplifying it, as this guy who was building the largest possible innate symbolic system. And that's just not a correct characterization. He thought you need to build that as part of the larger whole, but he was always, I think, with an eye towards how are we going to put this into a larger system.
So I think Doug can also be characterized as one of the scruffiest people in AI ever. We've got one of the people who joined the Psych project early on was Guha, who also invented RDF and has led and is perhaps the most important single person leading to the current idea of knowledge graphs or schema-free large knowledge bases. So Guha also recorded a video for his reflections on Psych. He brought some rigor to Psych, but only as much as he could. So let's play the video from Guha.
Hi, my name is Ari Guha, and I worked at Psych when it was a research project at MCC. Doug was my boss, my thesis advisor, my mentor. I started on Psych as an intern summer of 1987 and transitioned to a full-time employee that fall. I continued on Psych till it was at MCC. Over that period, I worked with Doug and John McCarthy and Stuart Russell and others on PsychL, the language in which Psych is written, the upper levels of the Psych ontology, and many of the tools like the database integration tool in the natural language system. Doug and I co-authored many publications together, including the book on Psych and many papers that appeared in the communications of the ACM, AI Magazine, and other places. I don't think I have worked with anyone else that closely for an extended period of time. There are three intellectual facets of Doug that I would like to make some remarks on. He was one of the first to understand the real power of AI systems comes from the large amounts of knowledge about the world that they have. The focus being on the knowledge, not on the formalism used to encode the knowledge or the particular reasoning mechanisms used to derive conclusions from that knowledge. The paper that Doug and Feigenbaum wrote back in the mid-80s called On the Thresholds of Knowledge was one of the first to lay this out very clearly. This message was much broader than just the context of symbolic AI. As Jeff Hinton, who comes from a very different school of AI, told me recently, Doug Lenat was a pioneer in understanding that the central problem of AI was how to get a huge amount of knowledge into the system. High praise indeed. The second amazing thing about him was his courage in taking on really big challenges. Today, the idea of aggregating a very large amount of data as the first step in creating an AI system is taken for granted. When he set out to do that in 1984, souped-up Lisp machines had only 8 megabytes of memory and ran at a couple of megahertz. More importantly, none of the information infrastructure that we today take for granted existed. The web, the prevalence of open source, things like the Common Crawl, and so on. Doug and the team rolled up its collective sleeve and started to work. The third, and probably the most remarkable side to him, was his willingness to change his mind, broaden his scope of thinking, and pivot directions. He did this when he moved on from automated discovery in the context of his PhD thesis, AM and Heurisco, to Psych. And then he did this several times in Psych itself. When Psych started, the aim was to build something more akin to what we today would call a knowledge graph. A combination of folks, including John McCarthy and others, convinced him that it will be far more interesting to try and replicate what a 5-year-old can do, which led to a much bigger focus on basic common sense reasoning. As Psych matured, he added a focus on applications such as database integration and natural language interfaces. I'm sure that in the years since the founding of Cycorp, many further areas of focus have been added. Perhaps the most striking example of this ability to adopt new ways of thinking was something that I got to play a role in. In the beginning, Psych was a card-carrying member of the so-called scruffy school of AI, where the focus was on the functionality of the system and not on the architecture of the system or the principles or the theoretical considerations. Slowly, Doug saw the value of standing on firmer ground. We first cleaned up the representational basics of Psych-L and then introduced a number of constructs, starting with the idea of separate epistemological and heuristic levels, and then argumentation-based reasoning and in the concept of micro-theories or contexts. Later, many of the representation ideas that arose in Psych-L, like making classes, properties, etc., first-class entities into representation, found their way into the core layers of the semantic web in things like RDF. Today, many of these have found use well beyond AI systems, including the modern world of knowledge graphs, which power many of today's king applications like web search. It's been 30 years since I worked closely with Doug, and the intervening years have only made me appreciate him more. Having closely interacted with hundreds of scientists and engineers in the years since, I now realize how truly extraordinary Doug was in his intellectual breadth, in his flexibility, and his intelligence. Years from now, when we look back at the evolution of AI systems and the key insights that drove breakthroughs, I hope Doug gets the credit for being one of the first to not just clearly state the centrality of world knowledge, but also being the first to actually try to do something about it. Doug was also very special as a teacher, as an advisor, teaching me how to think, how to talk, how to write, and dare I say, how to be a better person. I will forever be in his debt. Thank you, Doug.
More wonderful remarks. If you have things you urgently want to say, we can say them, or we can move on. Brief remarks, and then we'll.
Yeah, so just one point also to follow up what Guha said, but also what you said earlier. That yes, I would say earlier on I said the focus is knowledge, but really the focus was also this neuro-symbolic combination. And what you read at the end of the paper, these 5 ways of combining them, maybe there are even more. And I really believe that this is where we need to focus on, to advance AI in a way that again can be really useful in isolation, but also together, especially with human beings. And so the symbolic nature of psych or others are really essential to provide the reliability and the validation and that is needed to complement the other capabilities that large language models or other neuro approaches can give that are not in a symbolic system.
I'll jump in and then go to Blake. We've underemphasized reasoning today, I think.
Yeah.
The other part of the final paper that Doug wrote and that I helped with was really about reasoning. I think Doug was the most astute understander of reasoning that I have ever met. He both had an incredible sense of where machines were likely to go wrong and also where humans went wrong. He was under no illusions that humans were good reasoners. He had an astonishingly subtle sense of what is important in reasoning. So the first part of the paper is really about all the challenges in reasoning that current AI systems are just not really flexible enough to do reliably. So, I mean, I guess in a way I'm saying y'all should read that paper. It's a really good paper. And it's exactly on the intersection of reasoning and how we can bring all these systems together. Blake?
Yes, I want to pick up on that point and also bring us back to the notion of scruffiness. So many folks who work in the space of reasoning are committed to features like decidability and completeness, but Doug saw that it was very important to look beyond that, not to overly commit oneself to such ideals, because what was most important to him was building a system that captured the full nuance of consensus reality. And so, he would often use metaphors like try to imagine writing the entirety of The Lord of the Rings or of Shakespeare's sonnets merely in triples, and you can see what an awkward construction that would end up with. So that's why we committed to higher order context logic, building off of Guha's thesis on context logic, and being able to quantify over relations, sentences as terms, to have arbitrarily many functionally denoted terms and things like this, which took us well beyond decidable and complete logics into very expressive languages to capturing the full nuance of reality as we know and experience it. And so that was incredibly important to him. Also, at the same time, building a scruffy engineered system that was able to reason soundly over those representations, deeply important. And he would always introspect on how he himself would reason, as Gary's pointing out. And he had these brilliant analyses of all the rules that he himself was using whenever he was thinking about almost anything. And so this was very inspiring.
So I wanted to flag one thing, that one of the main parts of Guha's and Doug's work together was on the handling of contexts. And you can think of that as like, how do you maintain multiple world models, right, in a way where they can be applied? And if any of you are thinking of what can I take from this symbolic area to build my PhD thesis on, a proper handling of context and learning in the face of context or theory maintenance, that is an area where enormous strides can be made, and building on the work of Guha and of Doug.
In the interest of time, I'm going to go straight to Ken now. We're going to do Ken Forbus's video. Ken is a very well-known AI researcher in his own right at Northwestern, and he's also a consumer of some of the things that Psych and Doug have built. So can we play Ken Forbus's video?
Doug Lenat is one of the heroes of artificial intelligence. Psych is a landmark achievement that has pushed the state of the art in knowledge representation and reasoning and in AI more broadly. Before Psych, there were many who thought that building a million fact knowledge base was impossible. It was too complex. But now, of course, we have billion fact knowledge bases, so it is possible. Now, Psych made many advances. I'll just name two. The first is microtheories. Microtheories provide context and logical environments, and they are insanely useful if you're reasoning about complex situations. The second is pioneering the use of expressive higher-order logics for practical reasoning. These are great, for example, if you're translating to and from expressive natural language and you're trying to find good semantics and logic. So Doug and his team inspired many of us in AI. In my own group, we use OpenPsych representations daily, and it has saved us literally decades of work. We used to use research psych, but it turns out that our hypotheses about reasoning are very different. For us, analogy is more primitive than backchaining. And also, we need to freely redistribute the things we build. So let me give you an example of what I mean. So CogSketch, or Sketch Understanding System, takes digital ink, or nowadays images also, and produces predicate calculus representations describing the visual and spatial and conceptual properties of what it sees. This enables it to model high-level visual reasoning. And that ability to see things as people do has enabled it to be used in new kinds of educational software. So sketch worksheets, for example, are authored by instructors and use analogy to automatically provide advice by comparing student work with an instructor's solution sketch. So what's really key is instructors who build these things are not knowledge representation experts. They're using CogSketch to do the work. And so you have these people who are using psych-based representations every day without actually knowing it. To them, they're just able to pose questions via sketches and able to get feedback about their sketches. So what's next? What can we do to further build on this legacy? I think my group's work demonstrates that psych's ontology and representations can be used by other representation and reasoning and learning systems beyond psych itself. And I think the field should double down on this bet. So we can use modern methods of machine learning to flesh out the knowledge-based contents, especially discovering techniques to do expressive higher-order knowledge of the kind of thing that complements the kind of low-level fact-based ingestion that happens now in commercial knowledge graphs. Second, build an ecosystem of open-source reasoning engines and tools to help people build novel forms of reasoning and learning systems without having to start from scratch. Now, to that end, my group makes available what we call NextKB. NextKB consists of the material we distill from multiple versions of OpenPsych, along with our own contributions in qualitative reasoning, analogy, visual and spatial reasoning, and also natural language resources for English. All Creative Commons attribution licensed, and there's documentation and systems that help you get up to speed on using it. So I invite you to join us in building on Doug's legacy and building open knowledge bases and open reasoning systems that will help accelerate progress in artificial intelligence.
User of Psych, and he's built NextKB, which you should all take a look at. Next, we're going to hear from Dave Fuchi, who is one of the largest commercial efforts to use the sort of reasoning and the sort of knowledge that Psych uses at the moment, and they've just been releasing some white papers about what they've achieved. And there's a direct connection from Dave's work back to Cycorp. We worked together in the early 2000s on projects which sort of led both to the current state of Psych and to elemental cognition. So now we will hear from Dave Fuchi.
Started in artificial intelligence very early in my life. I was impassioned by the vision of machines becoming our trusted thought partners, helping us think, helping us solve complex problems, reasoning far better than we could alone, to ultimately advance the human race for the better. Doug's personal leadership and his work through Psych was an inspiration to me and to many others in the field, well before it was popular, and even through the times when AI was very unpopular. I had the pleasure to meet Doug in person on several occasions. His commitment to the AI vision was deeply felt. It was positive, remarkably articulate, strong, and truly unwavering. Every field of study goes through remarkable transformation as it matures through theory and practice and in the context of ever-changing externalities. AI is, of course, no exception. Every advancement along the way is built on the successes and the failures weathered by the pioneers that had the conviction to lead. Doug had a point of view very early on, and that was that to reason effectively, to fundamentally automate the sort of intelligence we should expect from AI, machines needed access to knowledge. Knowledge defined primarily by mathematical representations that are subject to formal, trusted reasoning methods. I believe he was right. But at the same time, access to the massive amounts of common sense knowledge needed to fill the gaps in any robust logical argument was indeed elusive. Now, with the power of deep learning and the massive compute applied to build statistical models of human language, AI can reach for common sense knowledge through the application of large language models. LLMs, however, represent just a thin projection of the underlying processes that generate the language in the first place, and fail to give rise to the sort of intelligence we ultimately need to trust. It is my belief that the future of trusted AI will derive access to common sense knowledge through the power of LLMs, but will transform statistical patterns of language into logical knowledge representations and deploy formal reasoning methods that are transparent, precise, and trusted. Our vision of AI, and I think Doug would agree, must go beyond mimicry, bias, and the manipulation of language alone, and must demand knowledge, truth, and precise, traceable reasoning methods that ultimately better our thinking. We owe a special gratitude to those amongst us like Doug who led early when the trails were harder to fathom, more difficult to believe, and far tougher to navigate. We owe Doug Lenat great thanks for his unwavering leadership in the field of AI.
Thank you, David. My understanding is that we go to 10:45 and that the clock here is hallucinating. Is that correct? Does anybody have a schedule at hand? So I believe we go to 10:45, which would give us a little tiny bit of time for questions. But first, Blake is going to kind of give us the view from the ground at Psych right now.
Yeah, absolutely. So I do want to give some perspective on 30 years or more on where Psych is today, because I think that's a little understood, and I'd love you all to know about that. So in terms of real brass tacks, today Psych is not an approach, it's not research, it's real operational software that's delivering value to enterprise customers across the US. So it's real software, it's Doug's life work, and it's realized its value, it's being applied and used broadly. But what is it, and where can it go from here? Like I said earlier, we're at this exciting knee of the curve right now where we're seeing that LLMs can populate Psych autonomously, and Psych can in turn go back and validate LLM output and serve up the missing common sense that LLMs lack. So we can export billions, up to hundreds of trillions of common sense facts and lines of reasoning for LLMs to train on. And Psych can vote up or down outputs from LLMs in terms of validating their outputs and rejecting them when necessary, right? So how does it do this? Well, it is currently a KB consisting of 25 million axioms written in this higher order logic that I was talking about before. That might sound like a big-ish number, like, or it might sound rather small, right? So people have been working for 30 plus years. Often they have come up with more than 25 million axioms. Well, we had a devotion to making sure that those axioms were each as information rich as possible. So that 25 million axioms constitutes this crystal or kernel that Michael was talking about earlier, a crystal of knowledge which can be expanded on demand at inference time through transitivity properties, backchaining, and so forth, into as many, arbitrarily many, infinitely many, really, axioms as needed. Of course, as you get into the quadrillions, those become, possibly trivial variations of one another, but at least into the hundreds of trillions, they are substantial and interesting. So the KB consists of these axioms, which are really rules of thumb about the way the world is structured. So general principles like, if you own an object, you own all of its parts, right? A rule of thumb like that, which is at least default true. So the logic in psych is also non-monotonic and open to exceptions at any point in different contexts and so forth. Or other rules of thumb like, if you observe a physical body with an opaque outer surface, you can't see its inner parts, that sort of thing. So these axioms, these 25 million axioms, are these general default true, context-specific, highly expressive facts about consensus reality. And these are paired with an inference engine, which is not a theorem prover, but is this a scruffily engineered set of thousands of reasoning modules, which are optimized to handle specific reasoning problems. Like there's one module that's devoted specifically to handling transitivity, and there's another one that's devoted to, say, specifically accessing a particular external data source that has a class of knowledge which might be needed to solve certain problems, that sort of thing. So there are thousands of these operating in something like a Blackboard system where they apply when relevant to solving problems in inference search. So those are the two key pieces of psych as it exists now, that kernel of 25 million axioms representing consensus reality, which is really also just a scaffolding, right? Because as we were talking about before, it needs to go beyond the knee of the curve and leverage everything that it can get in terms of autonomously learning more, filling in the blanks about what it doesn't already know by reaching out to systems like LLMs that are available today. Yeah, so I think that's what I wanted to cover in terms of...
I'm going to make a brief observation. Maybe we'll take a couple comments from here, and then we will, in fact, have time for questions. My human-in-the-loop correction mechanism worked on the clock. We have 20 minutes left.
All right.
So brief observation is almost everybody here probably saw videos from Sora a week ago, OpenAI's system, and they're spectacular, but you look at them and there are limits to them. They're all these slow motion panning, but they also have a lot of violations of common sense in physics. So one of the things I would imagine psych has some representation of it is if you have a certain number of legs, other things being equal, at time t, you probably have the same number of legs at t plus 1. And there's a video of Sora with a cat that goes back and forth. Sometimes it has 4 legs, sometimes it has 3 legs. It goes back and forth and back and forth. Another thing that I'm certain must be in psych is if you exist at time t, other things being equal, you exist at time t1. And there are interesting Sora videos where people just come and go, or wolf pups come and go, and so forth. And so it's a really interesting question. Like, we have this spectacular, probably billion-dollar model that in some ways is just unbelievably good, and in some ways is not capturing the basic stuff that Doug thought about all along. And like, how do we bridge those worlds? As Francesca said, and I think probably all of us agree on the panel, I think we, at least on the panel, think we need some kind of neuro-symbolic integration that can bring together these kinds of symbolic constraints and knowledge and so forth with these kind of neural processes that can do this amazing bit of mimicry. I think this is still a very open, hot topic that we're nowhere near to solving. It's a great thing for future students to think about and so forth.
So just in my lab, one of the things we do is inference augmented training of large language models. It's much easier than you might think. Give it a try. What Gary's talking about, you might think that would be very hard to do. It doesn't have to be all that hard to do.
Yeah, absolutely. So I was talking earlier about how we could export so many truths that Psych can generate, and we're already seeing benefits like that on some of the benchmarks that are out there, like the ARC-C dev set. If Psych can export its relevant upper ontology, middle ontology, and especially, obviously the middle school science relevant facts, like arachnids have 8 legs or insects have 6 legs. These are very pertinent to helping LLMs. If we export those and fine-tune models like GPT 3.5 on those, we see that we augment their performance dramatically in terms of the accuracy that they can get on those benchmarks.
I'm going to insert one thing briefly, and then we'll go to Francesca, which is there was another video you were probably alluding to where it was a beautiful video of an ant walking through a colony, but, but the ant actually had only 4 legs. And what's interesting about that case is that probably almost all of the videos in which it was trained actually did have 6 legs, and yet the system still came up with 4, which suggests to me anyway that you want some output as well as constraints on input. That's part of why I think it's non-trivial.
Yeah. So no, I just want to follow up exactly on the last words you said, output verification and possibly, vetting, but also input. So I think that it's clear that there are many ways to combine, the neuro and the symbolic part. But it's still not, I think it's still a work in progress to understand how to combine them, what are the different ways of combining, and when it is appropriate to use one or the other one of these engines. Also, we have, symbolic reasoners that are very good, like Psych or other theory improvers or specialized even reasoners, and we are still debating, are LLMs reasoning or not, are capable of reasoning or not, but maybe they don't need to. Maybe we should use them for what they're good at, which is not reasoning, is learning from large amounts of data, and then extract that knowledge, whatever they've learned, and use them within another engine that can reason in a trustworthy way. So that's, of course, is for example, I think it's it's a naive pipeline approach, is what I think that the field of, for example, mechanistic interpretability does, to extract knowledge from from a large language model and then use it with a real reasoner that can do reasoning. So to me, the reasoning part is important. We want machines that can reason also to work and interact with human beings. But on the other hand, I have to admit that we cannot expect, and maybe we cannot even want to have machines that do exactly the same kind of reasoning that we do, because they should complement our ability. But at least we should be able to know and design them and know exactly what kind of reasoning they do.
Blake looks like he's dying to speak, then Michael, and then we'll take some questions. We'll have a little bit of time.
Oh, yeah. Just thoughts following up on Francesca, what Francesca was saying. Yeah, so I think that there's wonderful opportunities for pipeline/hybrid approaches. We see great successes with that in terms of, for example, alpha geometry. And I think that approaches like that are really, really promising. I do want to talk a little bit about the fact that when Psych reasons, it keeps track of all of the steps of its reasoning. And so it has this transparency aspect to what it's able to provide. Yeah, it provides this explainability. So it doesn't just come up with a deductive conclusion, but it actually can explain exactly why. And it can also do this in English. So all the axioms that Psych has and the ones that it can produce on the fly during deduction are translatable directly into English through Psych's NLG, which has all of these amazing features in terms of how it can actually communicate with LLMs, since most of them speak English, right?
And now we will turn to Benjamin.
Hi, this is a wonderful session. I personally knew Doug starting in about 82 and worked with him and for him actually briefly in 84, including in the first year of Psych. And many years later, I was his program manager for Paul Allen, where Doug had really influenced Paul Allen's thinking and what later then became the Allen Institute for AI. And I remember very well that Paul's first question to me when I was interviewing for the job working for Paul was, what do you think of Psych? And what are the lessons to learn, both positively and negatively? And so I think something that people might not realize is that Doug's legacy is firmly stamped on the Allen Institute for AI. I do think, though, that Doug had some limitations. One of them was that because he was trained or brought up, let's say, as a scruffy and had natural inclinations to that, Psych kind of peeled off from most of the rest of the field of logical knowledge representation and reasoning, KRR, at a fairly early point when it pioneered getting into things like higher order and defeasibility and so on by around 1990. But unfortunately, it then never reconverged or re-adhered. And so it was kind of split off and siloed from that point afterwards. However, the work with Psych that was done in the early phases of what became the Allen Institute replicated Psych-L and a lot of its language in a form that was more firmly connected to the main research community, and in particular standardized around logic programming. So the World Wide Web Consortium standards are based on extensions of declarative logic programs. Knowledge graphs are based on declarative logic programs. Relational databases, Sparkle, and knowledge graphs are all based on that logic. So Psych became close to, but not really integrated with that mainstream. And my question for Blake, and also I think Michael, who's thought about this quite a bit, is how should that affect our taking Doug's legacy into the future?
Yeah, I think a lot of the phenomena that you're describing in terms of the divergence or peeling off had to do with Doug's understanding that making commercially viable software meant focusing on customer needs, and that meant us, ultimately having to withdraw things like support for research psych and open psych for the larger community, and focusing on commercial development, supporting enterprise customers, and that sort of thing. So I think that that's just part of how that worked. But I actually wish that over the years I had come to more of these meetings. I've had such a fantastic time at AAAI this weekend, and I think that I know of 10 amazing papers we could have presented here. So I want to participate more in that in the future, even if we do just continue to pursue mostly commercial interests.
And I don't think the connection was complete. So, for example, Psych has a very powerful integration with SQL databases, right? Which is perhaps the most commonly implemented form of formal logic. And it's relatively easy to make a translation. If anything, I might argue for more scruffiness in a way. I think we're approaching a era where the development of logic-like languages will partially be handed over to machines, right? There are limitations on logics that we use. Why isn't common logic widely used? In part because it's complicated and human beings just can't handle that degree of complexity. So I think if we want, I think there's a universe of possible symbolic knowledge representations that will be, for example, very important for building scaled scientific models, right? And that there's an opportunity now to have machines participate in the design of those reasoners and of those representations, and in making them more reliable. And again, if you want a thesis topic, there's one to go after.
So we'll go to Louis, and then we'll have one last question and maybe final remarks if we have any time.
Thank you, Francesca, Gary, for organizing this. I remember in 2015 at Stanford, Gary was there, and one of the key questions that Doug asked and spoke about in that workshop was the need for explicit semi-formal reasoning. And I believe that, as Francesca put forward and Gary in many occasions, that these approaches that combine neuro-symbolic AI can provide for semi-formal reasoning. Can you expand, Mike and Blake, on the recent work or the latest work that Doug left on semi-formal reasoning? Because that could be a good way forward for neuro-symbolic AI and AI in general.
Yeah, so I think that I can expand on the transparency point that I was making earlier to help address this. So all of Psych's reasoning is done at obviously by the inference engines modules at the level of the logical representations in this expressive language of Psych-L. But The axioms themselves are these rules of thumb which are open to exceptions and which are only contextually true. And so I think that both of those features, the fact that these are default true and contextually true, helps make them in some sense semi-formal. So there are some contexts of reasoning which are going to be salient to different communities of interest. And the ones that psych leverages to generate its explanations in natural language for those highly articulated logic level proofs are going to be expressed to different consumers in ways that most meet their interests, right? So even if a step is at the logical level, even if a line of reasoning at the logical level inside of psych is hundreds of steps long, and psych can determine which pieces of those arguments are salient at any given point to a person's interest based on psych's model of them or based on psych's model of their community of interest. And it can only sort of articulate to them the pieces of the argument that it makes sense to them to understand. And we've seen that be of great value in terms of psych being able to explain itself relevantly to different kinds of consumers.
So Doug's key insight perhaps was that learning can happen efficiently at the frontier of knowledge, right? This was also one of the key insights of Leslie's talk. If you think about the explanations that psych produces in English, they're not quite in the English that you and I would produce. They're actually in a semi-formal version of English. And if we use those outputs to train language models, the semi-formality of that language can help them to converge on more effective logical reasoning, which will then help them to produce better hypotheses to build this crystal on the seed. So I think semi-formal versions of natural languages as well as more complex artificial languages are going to be part of this process.
I'm going to call on the last person, and then we'll all have a chance.
Yeah, thanks. So something interesting I've heard about psych is that at a certain size, it had to give up global consistency, and instead it just enforced consistency in local context. So what do you think that implies about, what consensus reality is, or is it consistent? Or
yeah, so absolutely. Actually, contexts enable this feature of psych. So psych doesn't have to be globally consistent. It's only consistent within each microtheory. So what that means is that, for example, we can represent different experts' perspectives on a technical problem, even if they're inconsistent. So if they have different means of thinking about a problem or different proposed solutions under different circumstances, those can be captured in expert-specific microtheories. So that's one very common use we have of microtheories, in particular if we're trying to represent different doctors' perspectives on disease states or different engineers' perspectives on oil well states, that sort of thing. Those can be captured in independent contexts. Another incredibly useful feature of context is that one dimension of context space is the temporal dimension. And so certain things are only true at specific times. Like right now, Joe Biden is president, but at some prior point in time, someone else was president, and someone else was president at a different point in time before that. So it's simply not true right now that Obama is president, though there is a context in which that is true. Right? So time has this feature of things only being true in certain temporal contexts. And so it's absolutely essential to everything. It's like every sentence in psych is only true within some context, even if that context happens to be the always, everywhere, every possible world context. That is a context in which those things are true. Like that, there are infinitely many integers. We take that to be metaphysically necessary and true always and everywhere. But that itself is a particular context in which those things are true. Is there a follow-up there? Did I address your question?
Yeah, pretty much.
Okay.
I think. I mean, yeah, I could ask some follow-ups, but I think
the interest of, we only have 4.5 minutes. We'll see if our panelists want to add any last thoughts.
Yes. So, well, I wanted to a bit summarize in my head, all the things that we said, and of course the focus on knowledge, on reasoning, on trust, on neuro-symbolic as one way of possibly achieving this combination of things, and you have machines that are useful for us and can work together with us, not necessarily reasoning the same way that we do. But also I would like to mention, especially to the young people, to really reflect about this contribution of Psych and Doug's pioneering work, of not being afraid of doing something different, even if it seems a bit, too ambitious or too difficult. You may remember that when Doug started, there was no internet, there was not a lot of data available, there was not the compute that we have right now. So it was really something that looked so ambitious, so impossible. And so not to be afraid, because as you see, that work had I agree with Benjamin that maybe it diverged and worked in a silo, which is a bit separated from the mainstream, but you can see how much it influenced a lot of the direction of research that were taken, and up to now since then. So really, don't be afraid to do something very ambitious.
So Doug was a very keen, as Blake said, observer of how human beings reasoned, but that doesn't, not in the service of copying how we reason, but in the service of expanding the ways that humanity might be able to reason and build knowledge. Now, one of the things about human reasoning is that we tend to have great difficulty maintaining different theories. We don't even have a micro-theory representation. So it's very natural for us to take different streams of research and oppose them to each other and say, a neural network or statistical learning is successful, therefore this other field is unsuccessful, or that logic is necessary to the future of AI, right? None of these things are nearly as definitely true as we, flawed human beings need to believe that they are. And I think it's very important to remind ourselves of this. Doug, although he was as human as any of us, was perhaps the least susceptible to these sorts of cognitive biases and the most inclined to question them in himself and others. I think this, if there's one thing that I think influenced me the most that Doug did, it was teaching me to distrust my thinking and acting on the results of the initial results of the initial thinking. Please, as a field, let us practice more of that kind of ecumenical point of view, and perhaps if we have to store them in micro theories, that's better than not doing it at all.
I'll take the last word. I was in this very room, I think, or one of the rooms in this building once when I spoke to some young students at what was then called the NIPS conference, now NeurIPS conference. And not everybody there, in fact, many people there didn't know Doug's work. And I think reflecting on something that Michael just said and that Alan said earlier, I don't know that everything that Doug said was right. And I don't think Doug would believe that everything that he said was right. But I think that the important point is the kind of rational self-reflection on the problems that he raised is incredibly important. What I said to the students then was, you don't have to agree with Doug, but you have to have a view about how to solve the problems that he was trying to raise. And if you don't really understand what the challenge of AI is. And so I hope that we've reflected today, not only on Doug as a wonderful and interesting, fantastic colleague in so many ways, but also as someone who raised a set of issues that we are still struggling with, 30 and 40 years after he laid them out on the table. There's still some of the most important questions out there. And so we were honored to celebrate him. I want to thank our panelists who are not here and our panelists who are here, and thank our audience. Thank you very much.